Hi guys. What we're doing right now is I am leaving you a video for when I'm gone to talk about how we manage solving equations that have fractional coefficients. So I'm going to try to see if I can put together a decent enough video for you in terms of what we're doing. Um, what you're going to do with something that has fractional coefficients. Let me just make sure that I kind of explain what we're doing. In the case of this, we are just solving equations, okay? That is our key. We are solving equations. And the reason why that's important is because, guys, you've been solving equations forever. There's tons of different ways of doing this, and I'm not worried about you knowing how to do that. But ultimately, when we talk about having fractional coefficients, what this means is some multipliers are fractions. It's not really that big of a deal that that is the case. But the part about it that's different with this than something we're going to be doing later in section 5.9 is there are no variables in the denominator. And that's what makes this a little bit different than solving what we call fractional equations, okay? That's going to be something that we're going to be dealing with in another section. But here, it's really just dealing with them as numbers themselves. And what I would say when we start thinking about something like this, the easiest way to manage it is this is kind of like method 2 with complex fractions. And I'm going to show you why in just a second, but I think it's probably not hard to see what's going to happen. Now, I'm going to start as simple as I possibly can with something like this, just to give you the super most basic way of doing it. So we're going to just kind of build these things up as we go. So my first example is going to be basic as it possibly can be. So we're going to have 2x over 9 plus 5 is equal to 13. Now, guys, here's the thing. When I'm dealing with something like this, like there's lots of things that we can do to solve the equations. You guys have solved equations like this forever. But what I would do is move that 5 to the other side and then get rid of the fraction. That's normally what I would do. What I want you to start to think about with a problem like this, because it's the way that it works for ones that have larger fractions, is to go through a process that kind of looks like this. The first thing you want to do is find the LCD, least common denominator, for the whole equation. Now, not going to lie to you. When we're looking at something like this, easiest thing that we can do for something like that is there's only one fraction, the least common denominator in this case, is that denominator. It's 9. Second thing that you do after that is multiply both sides of the equation by 9. Yeah. You guys are all catching a video right now where I'm going to be talking to somebody, but it doesn't matter. As long as he doesn't swear, it's okay. What's up?
Never mind. I'm going to ask you to watch my class, but never mind.
I'm sorry, man. I'm just doing a video for what I'm gone. That was my next door neighbor teacher. He apparently has to use the bathroom. I feel bad about the fact that I can't do that, but it's the way this goes every once in a while. Okay, so we're multiplying both sides by 9. This is like when you multiply the numerator and the denominator of a complex fraction by the number to make everything cancel out. So for me, I'm looking at that 9 there. What I'm going to do then is I'm going to take that 9 and I'm going to multiply both sides of my equation by that thing. So here, it's the 9 times the 13, and here it's the 9 times the 2x over 9 plus 5. Now, guys, I'm going to show you these steps in painstaking detail because I think it's going to be easier for you to see what happens as you do this. So here, if I multiply both of those things in there, and I multiply the 9 times the 13, then when I'm looking at something like this, here, I'm going to be getting, 27 is 117. So this will be 117. Then here, when I do the 9 times the 5, I'm actually going to write this part out because I'm distributing it. So I'm going to be doing the 9 times the 5. It's addition, so it's going to stay addition. And then here, I've got that 2x over 9, and I'm going to be multiplying that by the 9 as well. And the reason why I want to write it separately is because what tends to happen is that people don't really think about what they're doing when they do this multiplication. Like, I think you guys are going to have no problem with the numbers. 9 times 5, I know you know that's 45. That's going to be great. It's this part here that a lot of times if people are going to do it, they do 9 times the top and the bottom. What I really want you to think about is we've been simplifying problems like this for a really long time. And so that if I'm going to look at this, I try to think of it as a 9 over 1, so that when we multiply them, I'm really kind of looking to see, well, if I have this all on the top and all on the bottom, are there any common factors that I have in the top and the bottom that can divide out? And in this case, yeah, there are. That 9 and that 9 divide out and leaves behind, well, the 1 on the bottom and then this 2x on the top. And that's the reason why I'm multiplying both sides by the least common denominators, because I want them to completely cancel out. Now, all I have left here is a 2x. And now my equation has 0 fractions. So I'll be dealing with 2x plus 45 is equal to 117. And then all I got to do is just solve it like we do. Minus 45 from both sides. And so in this case, I'm going to have 2x is equal to 72. Took a second to do the math in my head. Sorry about that. And then if I divide both sides by 2, I'm going to get that x is equal to 36, which is super easy, right? Like we get the general idea. You find the LCD, we multiply it. It's good. That's totally all you're going to have to do with these. What becomes more complicated is when you get more fractions, right? It's fine. You just have to kind of think about it. But this at its core is the way that we go about doing these problems. So that's the first page of this. Most of what I'm going to do is just give you a couple other examples, and then I'm going to say, go and do the worksheet. Not the worksheet, the work from the book. Okay, so then the next thing that we're going to be doing for something like this is I'll give you a secondary example here. Let's go, well, let's make it a little bit more complicated. We're going to put x over 10 plus x minus 2 over 14 is equal to 1. Now, again, I want us to find the LCD, least common denominator. Here's what I suggest doing. When you're doing something like this, before you do anything else, look at how many fractions you have, and you're going to factor them. Now, when I say factor them, I'm just saying break them down into the numbers that are being multiplied. Because if I'm going to do this the right way, I need to multiply it by something that will cancel everything out. So here's what we're going to do. Like right now, what I'm looking at is I've got a 10 and a 14. If I break them down, the thing that they both have in common is a 2. So this is x over 2 times 5, and this is x minus 2 over 2 times 7 is equal to 1. Therefore, if I'm looking for the least common denominator, well, I need all of those things. So I need to have a 2, a 5, and a 7 to make that work. Because if I'm the 2, the 5, and the 7 will give me the least common denominator, just like we did when we were adding our fractions earlier. So in this case, that means that the least common denominator for this will be 70. Okay, so what I'm going to do is multiply both sides of this equation by that number there. Now, I'm going to show you the way I do it because I think that it's probably easier to do. I'm going to write this on both sides of the equation, but instead of writing 70, I'm going to write 2, 5, and 7. And the reason I'm writing it that way is because it's easier to see then what cancels out. Now, you guys know that that's 70. So it's not a problem. It's just something that we have to think about. So here, when I multiply those two things, it's times 1. Nothing is going to cancel. So we're just going to have 70 left over there. That's 2, 5, and 7. Here, I am going to write this with both things in place so you can see what happens. Again, if you don't want to do this, you certainly don't have to. But if I'm multiplying both of these things by that 2, 5, and 7, then it's easier for me to see what is going to cancel out and divide to be gone. In this first case here, my 2 cancels, my 5 cancels, I'm still left with that 7. So that means when I do that work there, I'm going to have 7x plus here, 2 cancels, 7 cancels, I'm left with that 5. So I'm going to have 5. And since there's 2 terms here, I've got to put it in parentheses. X minus 2 is equal to 70. And so now I'm just solving. So, all right, I simplify here. I'm going to distribute there. We're going to get 7x plus 5x minus 10 is equal to 70. Then I'm going to combine my like terms here and get 12x minus 10 is equal to 70. Then I am going to add that 10 to both sides. And I'm going to get that 12x is equal to 80. And then I'm going to take both sides of this and divide by 12. Now, 80 doesn't actually divide evenly by 12, but it does reduce because they both divide by 4. So that means at the end of this, this divided by 4 is going to give you 20. This divided by 4 is going to give you 3. So my final answer for this is 20 over 3. Again, we're not looking for anything that's designed to be difficult. I'm just looking at it in a way that I want you to be able to go, oh, I see what's supposed to happen here. Now, everybody feeling okay? I don't know why I'm asking you because it's a video, but I've got one more example to show you. And you're going to go, oh, I get this. Or you're not. But I'm not even here to see it. So what I would say is, if you're not sure, rewind this video and say, oh, I see what we have to do. Okay, final example. I have got x squared over 2. It is equal to 2x over 15 plus 1 over 10. Again, I'm looking for a least common denominator. And in the case of this one, I can tell you right now that it is going to be 30. But to show you again what I'm doing, here I've got the 2. 2 has nothing in common here, but this is a 5 and a 3. And this right here is a 5 and a 2. So if we think about all of the things that we're going to need to have, we need to have a 2, we need to have a 5, and we need to have a 3 to get there. 2, 5, and 3 together, that gives you a 30. Now, I know you guys can look at this yourselves and go, oh, I see what I'm supposed to do. But it is something to kind of go, oh, well, I've got to kind of think about what's going to happen. So with that, I'm going to multiply both sides of this equation by, for this one, I'm going to do it with 30 so we can look at what it looks like for that. If you do it with the 2, 5, and the 3, that's totally fine as well. But for me, I think it's okay to do it as the 30 so that as we do this work, we can go, oh, I see what's about to happen. Now, rewriting it, if I've got 30 over 1 times the x squared over 2 here, I can see what's going to cancel. Then I'm going to have 30 over 1 and that 2x over 15. And then I'm going to have that 30 over 1 and that 1 over 10. Now, each of these things divides evenly by 30. So when I cancel them out, I have to leave behind what is going to be behind. If both of those divide by 2, I will be leaving a 15 behind there. These both divide by 15, I will be leaving a 2 behind there. And if these both divide by 10, I'm going to be leaving a 3 behind there. So if I rewrite what I have, this will be 15x squared equals 2 times 2x is 4x, and 3 times 1 is 3. Now, here's the part about this that is going to get a little bit confusing. And that's okay. When we're doing this, I'm going to have to get this now where it's a squared term. So I know that there's going to be 2 answers left. So what I do to solve that is I have to set it equal to 0 and solve. So for me, I'm going to take this and I'm going to move everything over to the side where I have a positive x squared. Now we've been factoring forever, but I'm not going to lie. When you have that 15 in front, it does feel a little bit painful. And I understand that. So as I'm going to look at it, here's what I would do. Rewrite the equation. We have 15x squared minus 4x minus 3 is equal to 0 because this cancels and this cancels. And we have them here. The fastest way to do it is just to kind of eyeball with what we're doing here. Because that right there is a -3, I know that I will have a positive and a negative. And most likely, when I'm doing something like this, it's probably going to be a -3 and a +1, just because we're going to have a negative number in here. Now, for me, I would look at it and think, how would I do this to be able to get myself to a point where it's going to be a 4x? So if I'm doing this in my head, I at least know that these are going to be x's. And then we just kind of got to think of the numbers. It's probably 5 times 3. So let's just look and see. If I put a 5 here, and I put a 3 here, Well, this will be, that clearly works there, and this works there. 5 times -3 is -15. 1 times 3 is 3, -15, and the 3 would give me a -12. That's too big. Okay, so let's flip them and see if that works. There's a 3 and there's a 5. 3 times -3 is -9. -9 plus the +5 is going to give you that -4. Okay, so that is the one that I want. That is going to be 3x plus 1, 5x minus 3. Now I could do this with the box and the x thing too, and might as well do it really quickly just so you guys see what that's going to look like. If I do this with that box and the x to be able to kind of do the factoring part of it, what I can do is this. 15x squared goes up in this corner. -3 goes down in this corner. -4x goes down here, and I multiply the two of those together to get the number up here in the top. That will be -45x squared. Then when I'm looking for the two numbers, they're going to multiply to -45 and add to -4. I will get a -9 times a +5, and that works for both. So if I put a 9x here, and excuse me, a -9x here, and a 5x here, then when I factor everything out, I can look and say, well, these two here have a 5 in common and an x, which means that here I would have to have a 3x, and here I would have to have a 1, here I would have to have a -3, and that works out for the corner. So it does work for the exact same thing. Either way you do it, it doesn't matter. We still get the same thing. Now, if I'm solving for what the x's are going to be, I basically am going to set both of those equal to 0 and solve because I am a little worried about time and because another class could be happening in a minute. In this case, what we generally do is say, well, I know that initially I'm going to have to get rid of that 1 with a -1 because there's 3 in front of here. I can have that divided by 3. Same idea here, since I'm going to have to get rid of that -3. It'll be a +3 here. And on this side, it's going to have to be divided by that 5 to get rid of the 1 that we have here. So my two answers will be -1/3 and 3/5. Now, there'll be problems that are like that. And it's going to take a little while to get to it. But ultimately, what you have here is a complete solution to how all of these are going to work. And that should be enough to kind of have us go through what we're going to do. So give it a shot. Try the problems we have for the check your understanding or the solution.